Okay, so this question here, again, it's we want to just solve this, get rid of the logs. The x's are inside the logs. We need to somehow get rid of the logs. The two basic ways of getting rid of logs is basically making log equal log and dropping the logs, or making into one log, combining all into one log, and using definitional log. For the most part, it's probably easier to make, for the question like this, make a log base A expression on this A, make one log base A expression on this side, and we can just drop the logs. Okay, so this is going to be divide. So we subtract means divide, and then there it is. Okay, we can now drop the logs. We're not canceling logs out or anything like that algebraically. It's not like it's times here. We're just making the argument that the inside of the log, this piece here, must equal this piece here if the exponents are equal. So then I end up with x plus 3 squared, which I'm going to, I'll write that out, x plus 3 squared over x squared minus 1, that's equal to 4. Now if I put it onto this side, it would be times, and notice that I'm going to have to times on that side to get the x out of the denominator. So I'm going to expand the numerator and then cross multiply to get rid of the denominator, and I get my quadratic equation, which I can solve for x. Okay, so make it equal to 0. I get 3x squared minus 6x minus 13. I don't think this is solve factorable, if I'm not mistaken. I don't think this is factorable, so I need to use my quadratic formula. X is equal to 6 plus minus square root of 36 minus 4 times A times C over 2A. Okay, this simplifies to 6 plus minus. That's going to be 52 times 3, so 156. So square root of 192, if my math is correct. Okay, and that's all over 6. Okay, and then we can simplify this. That has a common factor of, it looks like that's divisible by 16. Okay, so we end up with 6 plus minus 4, and that's going to be looks like 12. 12 times 16. Okay, and then we can actually factor out another 4 out of there, so we get 8 root 3. Okay, so 64 actually divides into there, and then simplify this fraction. We end up with 3 plus minus 4 root 3 over 3. Okay, now we have to check our solutions. We always have to check for extraneous solutions. Okay, and if we look here, the decimal values, I really should check the decimal values of this so that I know if it can be plugged back in. So I need to check for negatives. Okay, so 3 minus 4 root 3. Divided by 3. It's going to give you negative 1.31 about. So negative 1.31. No, that looks okay. Negative 1.31, if I plug it into here. Okay, that seems to be okay. That's going to give me a solution that is above 0. Same with this one here. Negative 1.31 is going to work out there. So I'll write out those values, negative 1.31. And then the other solution is going to be 3.31. And both of those solutions look like they are perfectly okay. Okay, but we do have to check to see if they are extraneous solutions.